Okay, what's up and welcome back to the channel. This is the Prokon Geek, and in today's video we're going to be continuing with the Prokon tutorials for absolute beginners in English. And in today's video, which is tutorial 14, we need to look at the rectangular column input and design for the rectangular column design module. So without wasting too much time, let's get right into the video. Okay, so previously we looked at the design scope and theory in tutorial 13, link in the description below. But now what we need to dive into is the input and design of the rectangular column design module in particular. Last time it was an overview of all the modules. Now we need to focus on the rectangular column design. So the first thing that we need to look at is the geometry input. As you can see, it is quite straightforward. First up, you have a section where you enter the dimensions of your column where you have H and B. Then next up, you have a section where you're supposed to enter the effective depths if you're still in the X and in the Y. And next up, you have where you enter the length between the supports. That is the effective, not the effective length of the column, that is self-calculated, but the actual length between the two supports out there on the field. That could be, say, between the ground floor and the upper floor. Then after the length section, you have where you enter the strength of your concrete and then where you enter the strength of your steel. So these are the material properties which you need to enter. After that, there's nothing much that you need to enter after geometry and materials. The next thing that we may want to focus on is where we have our parameters. So we talked a lot about the parameters in the previous video, that is tutorial 13, link in the description below. So see those videos before you actually see this one. It's a continuous series. So always watch the previous video before you move there. But what I just want to say for this one is we are going to be taking our column as unbraced, and also for the end conditions I have another video, link in the description again, where it is explained, but we're just going to be taking them as they are already on the screen. And remember, the effective length factor is self-calculated. Once you're done with the geometry input and the parameters, the next thing that you need to worry about is the load case or load input. Just remember, you can enter as many load cases as you want, but you just need to specify which load case it is. As you will see, another thing you will notice is if you don't specify what load case it is in the load case column, it will automatically assume whatever you enter in the description or the loads that you enter right here will be for the load case number that is preceding. So in this case, load case 1 has the DL, so all these loads in this column will be for load case 1. Then for load case 2, everything in these two rows will be for load case 2, because for this one we did not put 2 or 3, so it just assumes we are dealing with the previous load case that you specify, but it will not associate it with load case 1 because there's a 2. The same applies when you come to load case 3, as you can see, where you have the DL is for dead load, live load, and then the wind load. Now looking at the loads themselves, we need to look at this column where you have P. So P is the actual force, and just remember, positive means it's a compressive force and negative means it's a tension force. Personally, I don't know why you would have your dead load or live load as tension, or even want to design a column that will be under tension, because let's face it, that's like going to McDonald's, Chicken Inn or Wimpy or KFC and expecting to find a healthy meal. You really can't expect to design a column for for tension when you're using concrete. But remember, yes, the wind load will be tension because it will try to bring about tension within the column. But as you can see, the loading is quite low. It's not even significant. It's significant in this case that it's going to induce some moment, but then it's very small. So in case where you want to design for large loads, it doesn't make sense to make a concrete column for tension. Okay. Now, having said this, the next thing that we just need to look at as well under this is the moment. So you can enter a moment for the top and the bottom as well. That is in the Y and the X. Each have their own for the top and for the bottom. And one thing you just want to show is that use the same sign for the top and the bottom, because otherwise once you start using different signs, you are counteracting your columns. And just remember, counteracting your moments, And just remember, positive is an anti-clockwise moment and negative means it's a clockwise moment. Then one last thing that's important in this module that you need to note before we move to the design. I even have some notes which I'm going to give you in the description. All entered loads are affected ultimate loads, including the self weight of the column. Just remember that all the entered loads are affected ultimate loads, including self weight of the column. So whatever you're going to enter in this module, for example, when they say the dead load 245, this is the dead load after you do your takedowns and then multiply by the factor, which could be 1.2 if you're using SANS, 1.4 when you're using BS. Now that we have an understanding of everything in the input section, the next thing that we need to look at is the design section. So all you have to do when you want to design anything in Prokon, it's as easy as just clicking on design. There you have it. And the design has been carried out. Now you will ask me, really? Yes, it's a computer. It's a super fast computer. And you may remember, the right hand is fast, but the left hand is steady. If you watch The Gentleman, that's a cool movie. Please do watch it. Prokon is fast and steady. So at the moment you click on design, it will design it for you, and it also produce what I call a steady design for you. Everything is nice and neat. And some of you may be asking me, what exactly does it do when it's designing? Well, let me tell you something. It's simple. It just calculates the reinforcement that is needed for your moment. It's as simple as that. There's nothing fancy, no magic, nothing. Just calculating the reinforcement that you need. But obviously you might want to understand what you have on the screen. Now the other thing that may be important is when you see you have your design charts for the X and the Y. You can go through this. These are calculated using the equations in the codes. If you want a video on that, we can look into that, but just go into the code, you will understand where this comes from. Then when you go back to design, one important thing that you also need to note is when you see these moments about the axes, and in this case you have MX top, MX bottom, MX additional at the top and the bottom as well. So remember, if you're designing a slender column, in this case our column is slender due to its length, you have additional moments which are calculated depending on the slenderness of your column, and these will be added to the moments that you input in the input section. So on top of your moments, you are going to have the additional moments due to the slenderness, which are going to be added onto your design, and this will then be calculated to give you the reinforcement that you need for your design. So something that you might want to know is the meaning of everything that is now in this section where my mouse is. So what I did is, well, in the notes, if you go to the PPT, which I'm going to leave in the link in the description below, if you just click on this Microsoft Word, let's just wait for it to load, you will see that I've already given you the Prokon column module design output. This is the definition of everything that is there, because for me to start describing every little nitty-gritty that is on the screen for you may take some time. So what you can do is you can pause this video at this moment. As you can see, I'm scrolling through each statement or each term down to the bottom of the page. But the best thing is that this will be in the link in the description, so you don't have to worry yourself too much. But back to Prokon, I think a few things that you might just want to note is that by default, it gives you the results for the critical load case, which you can even cycle through your load cases. For example, if you go down this previous and next, so you can always choose which load case you want to see the results for. In this case, load case 1, then you can go to load case 2, then you can go to load case 3. And if when you're in load case 1, you can always go straight to the critical by clicking on the critical, and it will show you the critical load section. And remember, when it's doing its design, it designs for the top, the middle, and the bottom of the column. And in this case, you will see that it will have its figures. So normally the actual load is the same. When you have it at the top, it's going to be the same at the middle and at the bottom, but the moments will be dependent on where you entered them, remember. So for example, when you have MX, you have a bigger moment at the top as compared to the bottom, because this is all dependent on what you entered, right? And remember, it also selects the design axis for yourself, and whatever it does, it calculates the maximum moment that is occurring at that axis. So in this case, our design axis is the Y. That is why you have M prime Y. But if the design axis was the X, you're going to have M prime X. And after it's done is you go to AS, it calculates the moment, or should I say the area of steel that is required to counteract that moment, right? That is in the Y. Then it also calculates the percentage of steel. Remember, you don't want to go above 6%. So in this case, we had 1.74, which is undoubtedly the worst moment, which is 103.2. So the largest area of steel that's needed is 2,404. And then the percentage of steel is 1.74. Then remember, it has two axes, the Y and the X. So this is the area of steel required in the design axis, but then it also designs for the other axis and tells us it's going to need 553. This is mostly because I believe it's the nominal steel that is required. So the moment in that axis might actually be much lower, and you're just being provided with the nominal steel. So this is basically it when it comes to your design section. This is what the input, or should I say just the results that you're going to get. So of importance is just for you to go to where it says the area of still, then the percentages as well, to see if they've not gone beyond 6%. Then also remember, you can cycle through the design load cases, go to the critical, and you now know in case where you have a short column, you are not going to have any additional moments. And in the case where you don't have any moments entered, you're not also going to have these moments. But then in this case, since you have biaxial bending, it's also just included this moment so that you see what was used in the design in this case. As you can see, it's a superimposition. So what I want to do is let's wrap this video up here. I think you now have an understanding of the input and the design. And just remember, the design process is quite simple. It's just calculating the maximum reinforcement or the minimum reinforcement that is needed to cater for the moment that is applied on this column. So without wasting too much time, we're going to wrap the video right here, and then I'll see you in the next video where we're going to go over the calc sheets and the bending schedule. So without wasting too much time, let's wrap the video. Please remember to subscribe to my channel if you have not. Also remember to click the notifications button. Remember to leave a like, and also remember to leave a comment if you enjoy the video. Hopefully you're watching the videos until the very end. If you're not, bro, please just help me with the YouTube algorithm. You can download the videos, but at least just let them play until the very end. Laissez la vidéo jusqu'au tout le tout fort. So until next time, peace out.